Okay, this is from the TI Inspire document that I called End Behavior. So on this first screen, you are looking at a variety of functions. This one's linear. You have a cubic. And in this case, you have a fifth degree polynomial. So they are all of odd degrees. And you need to notice that the leading coefficient here is a positive 1. Here it would be positive 1. And even here, if we multiplied out all these factors, we would have a positive 1 on our x to the fifth. When the leading coefficient is positive, basically you're going to be looking at the same behavior as a line with a positive slope. So it's going to rise to the right and fall to the left. Now, that's not talking about what behavior is going on in the middle of the function. It's literally talking about the ends of the function. So this function would continue to go down and left and up and right. Same thing. Up and right, rises to the right, falls to the left. Now, let's switch it up and have a negative leading coefficient. So this line has a slope of -2, so we feel like it goes downhill, or falls to the right, rises to the left. Here is a negative 0.5x cubed, so it is rising to the left and falling to the right in the same general shape of a negative sloped line. This one looks like a negative x times, this would be an x squared, so that's a negative x cubed, would follow that same end behavior, down to the right, up to the left. Don't worry about what's going on here with this little dip and a bump. That's middle behavior. Okay, with an even power, even degree, our basic shape, our first shape that we learned was a parabola. This would have both ends up since the leading coefficient is positive. The leading coefficient here would be a 1. Leading coefficient on this one would also be a 1. And we would end up with x to the fourth power. Now, there's some crazy middle behavior going on both of these, but the ends, the end behavior, would both be going up. So we would say rises to the right and to the left. Last type, even degree, leading coefficient negative. So just like our basic parent function, negative x squared, both ends down, here, both ends down. You see the negative sign on the outside of our fourth power expression. Here, a negative x squared times another product of x times x. Total would be x to the fourth, negative as that lead coefficient, so you're going to have both ends down. Notice again some crazy behavior in between. This one, not so much crazy behavior in between, but both of these fourth power graphs have end behavior pointing down. That's a nice whirlwind tour through end behavior.